Who was it that said, if you think you understand quantum physics, you don't understand quantum physics?
That would be Richard Feynman, who also said about quantum entanglement that it is the heart of quantum mechanics and really the only mystery. And computers are going to work with quantum entanglement. It's going to drive an AI system in the future that I think could even be powerful enough to right now be affecting us from the future. Ha! So it's not D-Wave, though. Let's talk about what it is.
Google and NASA have teamed up to share one of the world's first commercial quantum computers. This machine, made by Canada's D-Wave, will be installed in a NASA research center in California.
Okay, did everyone catch that? So D-Wave plus NASA plus Google are teamed up together, and they have a quantum AI lab whose slogan on Google Plus is new updates from the Quantum AI Lab's corner of the multiverse. You guys are so clever and funny. So D-Wave is not the AI of the future. What they're trying to do is be the first of the quantum computers so that everyone will say D-Wave instead of quantum computer. It's kind of like how, we say Band-Aid instead of bandage, and we say Xerox instead of photocopy. Anyway, D-Wave is not the quantum computing of the future, and even their CEO, even D-Wave CEO says,
there are even other types of quantum computers that people are building. Microsoft has a really interesting project going on where they're trying to develop what's called a topological quantum computer. The problem is that type of computing will require the discovery of a particle called a non-abelian anyon, which physicists do believe exists, but they haven't actually been able to identify one.
So if you caught that, he was saying that they need an antimatter particle that has not yet been discovered. That's pretty sure of themselves because Microsoft has already opened up this platform. They've already hired people. They've already got it in development stage. They're dang sure that this particle is going to exist. I think they know the future. I think that there's an AI in the future that is smart. I mean, like brilliant. So let's talk about how a quantum computer works. It uses 3 basic principles of quantum mechanics. 1, superposition. That's basically when something can be in 2 or more places at the same time, which can lead to quantum entanglement, where 2 things, no matter how far apart they are in time or space, they act the same way at the same time because they're connected. And finally, quantum tunneling, which is possible because things are connected via quantum entanglement. They can move freely in between both universes, both superposition states. So quantum computing theoretically tries to use these quantum concepts to process information. So here's the AI lab guys to tell you about it. And they're about to use a whole bunch of words that you may or may not understand. Just don't worry about it. Know that they are not really the future, okay?
Consciousness, intelligence,
Free will, determinism,
black holes, protecting the planet from asteroids,
Heisenberg uncertainty principle,
atoms, ion traps, nuclear magnetic resonance, superconductors, photons,
artificial intelligence, machine learning,
past and future, classical physics, time travel. I mean, the whole thing. Quantum physics puts everything into question.
It defies every intuition you have about the natural world.
Quantum is a very strange regime of physics.
Things can exist in this state of superposition where they could be like ghosting on each other, where they could be this and that at the same time.
Entanglement. Quantum entanglement.
2 objects, if they're quantum mechanically entangled, are still strongly related to each other, even though they can be a vast distance apart.
one is quantum tunneling.
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 Tunneling is the slippage between universes.
For a long time, people thought those effects only existed in the microscopic domain.
Like atoms, electrons, photons.
But really, it's the theory of our universe.
So if you want to build a quantum computer, You want to incorporate those new phenomenon into information processing.
Maybe quantum.
All right, so let's review really quick. What is quantum computing? It utilizes superposition, which is something that can be in two or more states at once, and quantum entanglement, which is things that are connected no matter how far apart in time or space they are. They react the same way at the same moment to only one of them's surroundings, so they stay connected. And then finally, quantum tunneling, which is essentially just moving in between these universes, okay, because of their connectedness. So they're able to talk to each other in their separate realities or universes or states of being. And this is all fine and good as long as it's naturally occurring, because quantum entanglement can occur unnaturally due to CERN colliding particles together, and through those events of collision, quantum entanglement of many millions of particles happens, and those particles are thus quantum entangled forever. That is messing with matter in a way that, in my opinion, we shouldn't be doing. And now that quantum computers are on the rise, there are ways to manipulate these entangled particles into doing what we would like. So since there is a Microsoft platform for a quantum computing system that uses an antimatter particle, I would suggest that we know exactly how quantum computers work. So let's continue.
I was going to ask you to explain quantum computing, but...
Okay. Very simply, normal computers work by... No, don't interrupt me. Normal computers work either there's power going through a wire or not. It's 1 or a 0. They're binary systems. What quantum states allow for is much more complex information to be encoded into a single bit. Regular computer bit is either a 1 or a 0, on or off. A quantum state can be much more complex than that because, as we know, things can be both particle and wave at the same times, and the uncertainty around quantum states allows us to encode more information into a much smaller computer. So that's what's exciting about quantum computing, and that's what we're doing.
Quantum computing is a whole new category of computing, and it directly leverages the laws of quantum mechanics to do a computation. Quantum mechanics are the most fundamental laws in the universe. It describes how everything in the universe works. What we've built, we use those laws of quantum mechanics.
Quantum computers allow us to access hidden features of nature. We're looking at the dynamics of atoms and molecules, and they found that those atoms and molecules behave nothing like what you experience at macroscopic scales.
One of the fundamental building blocks, or the fundamental building block of a quantum computer, is a thing called a qubit. Q-U-B-I-T, right? So it's basically a bit, the lowest level building block of a computer today. It's either a 0 or a 1, but it can also be in what's called the superposition of 0 and 1. In other words, it could be in two states, 0 and 1 at the same time.
There's something called superposition. Say an electron is going from point A to B. Your common conception of how an object travels from one place to another is to take a single trajectory across space. Electrons actually take all possible paths simultaneously. Imagine that you're at point A and you have to go through a maze with 1 billion possible paths to escape. If you're a classical you, you're going to try one path, that didn't work, come back, and you could imagine it taking many, many lifetimes through 1 billion or never. But what if the same physical you could travel all those paths simultaneously? Another effect is quantum tunneling, wherein I can have an object on one side of an impenetrable barrier, and it will disappear and appear on the other side of that wall. If all of these different selves in these parallel streams of reality can talk to each other and collaborate, coherent evolution is when these paths can talk. Here you see a strip of film representing two realities, and when the two pieces of film are stuck together, we call that coherent evolution. They can talk to each other. That's another way that you could escape and explore domains that would otherwise be forbidden to you as a classical entity. And finally, quantum entanglement, which really bothered Albert Einstein. Example, imagine you had two pairs of dice, one in California, one in New York City. You roll them 1,000 times. But if you compare the die rolls 1,000 times out of 1,000 or 1,000,000 out of 1,000,000, they got the same result every time. It's as if the dice know about each other with no physical connection between them whatsoever. And that's how those disparate paths can talk to each other.
And superposition and entanglement is another quantum mechanical property.
When people started thinking about how to engineer systems based on this kind of quantum dynamics, there's something called qubits. So bits, what you're all used to, it's a 0 or 1, basically a switch that can be on or off. But what if I could build a device that could be in two possibilities simultaneously and then concatenate them into an array? To put it the way David Deutsch, the progenitor of this field, quantum computation will be the first technology that allows useful tasks to be formed in collaboration between parallel universes. Why is it if the universe at this microscopic scale behaves that way, and you're built out of those constituents, you're not doing that?
In fact, it's quite difficult to do.
Okay, here we're finally going to hear from the CEO himself why D-Wave is very limited in what they are able to do. They need a very cold environment for their quantum computation to even work.
The processor is a quantum computer.
So they need these huge giant refrigerators that keep it cold enough for there to be quantum computational processes that can work. And the quantum computer is actually just that black part that you see. It's just the chip. That's the whole quantum computer, but it can't work without the giant refrigerator. And that is why D-Wave is limited in what they can do.
The overwhelmingly obvious killer app for quantum computation is optimization.
What our buddy there, Jordy Rose from D-Wave, means by optimization is making it work correctly. And by the way, yes, he's the one who said that D-Wave leaning up against one is like being next to the altar of an alien god. And I thought he was the CEO, but apparently he's not. This guy, Vern, is. Anyway.
Because the enemy of quantum computing is the environment. Things like temperature. And when you have temperature, you have molecules moving around that cause interference to the quantum computation. You also have electromagnetic interference from radio sources and gamma rays and all sorts of things. So you need to create a very quiet, clean, cold environment for these chips. Ultimately, what we're building is a quantum computer on a chip that's about the size of your fingernail. So these machines run at a very low temperature so that they can have that pristine, very clean, quiet environment to run in, and it doesn't disturb that quantum computation. Very, very cold, very, very rarefied environment because we're also running in effectively a magnetic vacuum.
That's a very interesting choice of words there, a magnetic vacuum. Same principle behind how they get particle accelerators to work. Interesting. He also mentioned gamma rays earlier, which is one of the things that they are searching to find dark matter. But take a look at how happy and giddy he looks when he starts talking about aliens at random in just a second.
So you could consider these environments, these rigs that we built, these systems that we built to be probably the most rarefied environments in the universe, unless there's other intelligent life in the universe that has, purer, colder environments.
Say what? What you talking about, Willis?
For instance, outer space is 150 times warmer than the environment that we build for these quantum computations.
That makes me kind of wonder if dark matter is really like entities that need really cold environments to survive. Just crazy thoughts.
So you may ask, why do we go through all this trouble? The answer is the promise of quantum computing is exponential speed-ups over classical computing.
Wow, he said that really fast and eloquently.
Things like developing drugs for cancer or better modeling the molecular interactions of cancer and how it attacks cells and things like that.
Ah, okay, but when he lies, he doesn't talk eloquently.
Big data analysis, looking for patterns and inferences and drawing insight from large amounts of data.
Our computers already do that. Why would we need quantum ones?
Or doing things like better modeling financial services.
Oh, because it can do finances better. Gotcha.
Markets and better managing risk and so on. So there's all kind of applications that aren't particularly well suited by today's type of computers. And I refer to today's computers is classical computers. They compute largely in the same way they have for the past 60 or 70 years.
Newsflash, D-Wave is not that much better than classical
Why
computers.
would we need any more powerful computers? These problems that we're trying to solve
Right, the cancer and all the financial markets and everything
are incredibly hard problems and aren't well suited for the architecture of classical computing.
May I call bullshit, sir?
Quantum computing as another set of tools to develop and enhance some of these capabilities to really change the world.
Yeah, change the world, the universe, the reality, time, space.
D-Wave, with its choice of adiabatic quantum computing, has been very effective at solving real-world problems at real scale.
Yeah, I mean, they gave Scarecrow a gun and all kinds of other stuff.
We currently, as a civilization, we generate vast amounts of data. It could be climate data, genomic data.
Oh, wait. Genomic data? Why is Geordie Rose from D-Wave mentioning genomic data? That's uncool. Don't be messing with the genome, please, D-Wave.
It forces us to consider, more sophisticated notions of how the reality around us is actually shaped.
I can't ask it how long I'll live or the meaning of life. Really, we don't know what the best questions are to ask that computer. That's exactly what we're trying to understand now.
Okay, so let me just get this straight. We built this computer because we were gonna cure cancer and we need to implement these quantum level dynamics into our macro physical world. But we don't know really what its capabilities are. And Microsoft started building it without even knowing that the anion exists. The whole thing just seems backwards engineered to me. It's definitely fishy. Not to mention that D-Wave released their code so they could have everyone practice for free, open source. And that indicates to me that they don't really know how to use their own software, write their own code. It says quantum computing is real, but it's also hard. So hard that only a few developers, usually trained in quantum physics, advanced mathematics, or likely both, are likely to be able to do it. So they're fishing for people to write code for the software that they don't even have the imagination to do themselves. I mean, I don't know. That's an assumption. That's maybe unfair. But let's listen to the rest of the AI Lab's basically programming of your mind.
To me, the most important question is, are we alone? And I have a feeling that quantum computers, as they mature, are going to help us answer that question.
Oh, I think you have no idea there, buddy. I think they may have already answered the question, are we alone? And here's some globe Earth programming for you guys. Look, there's the sun and space. It's all real, everybody. Oh, but wait, it gets better. There's some one-eye Illuminati symbolism at the end of this, okay? Just hang on.
And big questions. Some of those will be addressed in D-Wave. Some will be addressed at NASA. And some at Google.
I wasn't sure
how amazing it is that we, with our monkey heritage and monkey brains and monkey fingers, have somehow lucked into a brain.
Ah, the Darwinism. Well, God made me. God made us, guys. That's what happened. And he loves you, by the way, all of us.
That human risk to go forth into that unknown frontier, whether it's space exploration or quantum exploration, we do it because we must. We do it because that's what it means to be human.
We do it because we are trying to change everybody's lives for the better, except all you poor people who make up most of everywhere on Earth. We don't care about you. Sorry, I'm a little pessimistic about this whole deal. Anyway, thank you guys for watching. Please give me your opinions, feedback. Let's talk about it. Thanks for watching and much love to everybody. Bye.